Okay guys, here's the notes for Wednesday the 10th. Now for 4 years we've been telling you that whenever you see this word rate, that just means slope. So really what we're talking about today is just a big lesson on slope. But today we're learning about the average rate of change. So before calculus we were finding slopes of lines. So here you've got a positive slope, here you've got a negative slope. Here, because this is vertical, my slope is undefined. And then here, because it's horizontal, my slope is 0. But after calculus, we're going to start finding slopes of curves. Now, one thing we know about slope, or an average rate of change, is that the average rate of change is always constant. So that creates a little bit of a problem because we're talking about the slope of a curve. If I have a curve on a graph, then obviously that line is not constant. Okay, so there's different ways of doing this. What you need to understand is that the slope of the curve right here is going to be different than the slope of the curve right here. And it's going to be different right here, and so on and so forth. Okay, so over here we've got a positive slope. Here we've got a negative slope. Here, if that was completely horizontal, we would say the slope is 0. Okay, and here we're back to positive. Okay, so as I move across this interval through these curves, my slope is changing depending on where I'm looking at the curve. So there's two different ways that we're going to deal with this problem. There's two different ways that we're going to find the slopes of curves. The one that we're really going to focus on is we're going to find the slope of a secant line. Okay. Now remember, a secant line is a line that goes through a curve, hitting the curve twice. Okay, when you find the slope of a secant line, what you're finding is the average rate of change over an interval. What that means is, if this is A and this is B, then from this point to this point, from A to B, we can draw a secant line. We're going to find the slope of that secant, which, as you can see, is really close to the slope of that curve. Okay, so what that is, what we're finding by finding the slope of that secant, we're finding the average rate of change. It's not the exact, but it's just really close. We could also find the slope of a tangent, but we're just going to need to know how to do calculus in order to do that. The slope of the tangent gives you the instantaneous rate of change. What that means, at a specific instant, at that point, that tangent line, remember that a tangent line just touches the curve at one point. Okay, so at A right there, at that exact instant, what is the slope of that curve? And we would have to use calculus to do so. So that's coming. That's coming for you guys next year. Now, let's go back to average rate of change. Now, guys, this is really simple. This is basically what you've been doing for the last 4 years. Okay? If we're finding the slope of that secant line, we're just taking f of b, which is right up here. There's f of b, minus f of a. So there's the difference in the rise, the y minus y, over the difference in x's, x minus x. Okay? And this is over the interval AB. Okay? Now, really simple. Let's take this first example. F of x equals the square root of x plus 1 on the outside over the interval 3 to 8. Okay? So we're going to find f of 8 if this is a and b. We're going to find f of 8 minus f of 3 and put that over 8 minus 3. So I plug in an 8 up here, I get the square root of 9, which is 3 plus 1, so I get 4, minus, plug in a 3 up there, I get 2 plus 1, 3 over 8 minus 3, so we get a 1 over 5. Okay, so what we just found, if you were just looking at the graph, we've got a square root graph that moved to left 1 and up 1. And that graph looks something like this. So from 3 to 8, okay, over that interval right there, pardon my crooked line, I know this is going to be bad. Okay, we just found the slope of that secant line, so what we found was the average rate of change. So the average rate of change on 3 to 8 on that particular interval is 1/5. Okay, it's not the exact slope of that curve, but it's pretty close, as you can see. And as you can see, it looks like you went up 1 and over 5. Now, one way of finding an average rate of change, you can actually use this method to get very, very close to the instantaneous rate of change. Okay, and this is something that I like to show my students. If I want, let's say that I don't know how to do calculus, but I want to know what the instantaneous rate of change is right there at 3. What I could do is shrink this interval. Instead of going 3 to 8, I could go 3 to 4. Okay, so I could shrink my interval, which would give me more of an exact slope there, or I could shrink it even more. I could go 3 to 3.1. Or what if I shrunk my interval to 3 to 3.00001? Okay, I could use this method right here just like we did. I could find the slope, but I could use this interval from 3 to 3.00001, okay, which is just a tiny little interval. So from here to here, I mean, just that little bitty bit, and that would give me a different, obviously a different slope, but that would get me a lot closer to the exact instantaneous rate of change. So you don't even have to know calculus to get really, really, really close to finding the rate of change at that specific instant. Okay, so let's move on. Let's move down here to example number 2. We're going to find the average rate of change of the population on 1995 to 1998. So we're looking for f of 1998 minus f of 1995 and we put that over 1998 minus 1995. So f of 1998 is 13,000. F of 1995 is 10,000. And then we put that over 3. And we get 1,000. So the average rate of change on the interval 1995 to 1998 is 1,000. We'll just say people per year. And that is how you find average rate of change.